short introduction from me that basically just shows the background to things. And then I'll hand over to the much more interesting and glamorous Professor Jason Brewer, who's going to make the settlement system turn somersaults. Okay. So I'm going to start off by talking about the background and the business requirements. So our objectives really were to have fully flexible settlement models. At the moment, we've got settlement models, we've had them for some time, but they're not completely they're not completely flexible because they are still based on the old style settlement windows that we used to have. Really what we want to be able to do is to support quite small settlement batches so that we can make sure that we isolate any problematic transfers in a relatively small batch rather than to have them in a large batch covering a whole day's worth of information. We also want to be able to deterministically assign payments to settlement batches. Now, one of the problems that implementers had in the past was that although there was a way of turning over, starting a new settlement window, there was no way of specifying which transfers should go in which settlement window. And that was a major problem, particularly when people were trying to align batches with, for instance, exchange rates that were valid for particular periods, those kinds of things. We also wanted to allow administrators to settle by criteria and not by batches. Again, if you wanted to settle in the old system, you had to know the identifying numbers of each of the batches that you wanted to settle, each of the windows. We want to allow much more intuitive criteria to be used to settle batches. So, fully flexible settlement models mean supporting all the types of settlement that we find in the real world. We mean it contains criteria in the settlement model for assigning payments to settlement models. That is to say, there should be rules in the settlement model that enable a system administrator to say, I want to settle transactions with these characteristics using this settlement model. They should also contain criteria for assigning payments to batches. And these are, in the first instance at least, they are time criteria. So what we're saying is, I want to start a new batch every 10 minutes. I want to start a new batch every hour. Those kinds of things. So that, for instance, for settlement models which have a large number of transfers going through them, people can choose quite small batch windows, whereas for ones that are less frequently used, they can select larger batch windows, maybe an hour, maybe even 2 hours, so that they can get small batches, but not have so many of them. We also want to enable administrators to view payments and settle them by characteristics and not by batch identifiers. So settling by criteria means something like this. It means I want to be able to settle all the payments between midday and 4 o'clock yesterday. Not I want to settle this batch, this batch, this batch, and this batch. And this creates what I want to call an actionable matrix. Now, its content can be dynamic. There's nothing to stop me saying, I'd like to settle all of the batches between now and the end of the day. Right? And that means that in that matrix, batches will occur that haven't yet been created because we haven't yet got there. But when they are created, they will be assigned to that batch because they meet the criteria, to that matrix, because they meet the criteria for that matrix. And an administrator can take actions on the matrix. You'll see this when Jason starts to demonstrate. Now, that doesn't mean that the action will be taken on every batch in the matrix. Because we're allowing matrices to be defined by criteria, it's possible that a batch, an individual batch, might occur in more than one matrix. So, for instance, a matrix can contain batches which are actionable, batches that are closed, or batches that might still have transfers added to them. And also batches which are, according to our definition, not actionable. And that includes, for instance, batches that are in dispute. If a batch is in dispute, I can't settle it. And they're also batches that are marked for settlement in another matrix. Now, if another matrix is being settled, the batches in that matrix can't be settled by some other matrix. So when you look at a matrix, again, you'll see this when Jason shows it to you, you can see the total of all the payments in the matrix and the total of the actionable batches in the matrix. And the total of the actionable batches in the matrix is the total that will be settled if you choose to settle that matrix. So it sounds complicated, but in practice, I think you'll see that it's not as complicated as it looks. We really wanted to make standard practice simple to enable people to say simple things like, I want to settle this set of transfers in this set of settlement batches. We found that meant that the edge cases and the error cases were more complicated to develop. But basically, we thought that was a trade-off worth making. And I hope that you'll agree when you see the astounding work that Jason's been doing. Hand over to Professor Brewer, to my left, and he will take you through the rest of the demonstration. Anybody want to? Right. The floor is yours. Oh, the floor is Sam's. Oh, okay. Sorry. I'll hand over to Sam.
Thank you, Michael. Hi, everyone. My name is Sam Kumari. I'm with the Modulo Foundation. Really appreciate those of you who are still able to focus and listen to all the technical presentations. I have a very small section for today, but I wanted to take this opportunity to thank Jason Brewer for the phenomenal work that he's done and everyone who supported him in leading the next generation of settlement. So this is now available with the newer code base, but we are looking at adapting that to the current code base or the production release like Modulo, Acacia, and Congo as well. Michael and Paul Macon have come up with some exhaustive and very specific requirements for settlement. And that's one of the reasons I want to appreciate Jason was that all those are taken into account and implemented to their satisfaction. So everybody likes it so much now that we want that as soon as possible available to the community. So there are some workshops that we are participating in to make that available. We need some development effort on that, but right now we are focused on the design. How do we get this working? How many of you here know how modulo transfers work? I don't know if this picture looks familiar to you, but for those of you who are familiar with the docs.moduloop.io, if you go to the technical section, there is a modulo transfers architecture. And there it lists out how the messages pass through various handlers. And primarily, there is one handler in the transfers or the clearing part called fulfill handler, which is like the last handler that handles the modulo transfer messages. So what we wanted to do at a high level was we wanted to take the next generation settlement service as it is now, and then replace the settlements components in current modulo implementation. For that, we needed to replace the API calls or the messages in the queues that were being sent by the various handlers, and replace that in a way that next generation settlement can work in as a drop-in replacement. So for that, we looked at the touch points, the interfaces, and this diagram here looks at various points. Like there were, I think, primarily 2 points that we wanted to highlight. Okay, there are too many boards for me to show this, but one was the incoming messages into the next gen settlement service, and there it needed to follow a specific format, like how the events are being generated now from transfers BC. So we were looking at that is one of the things that has to be done. And on the other side, once a settlement is done, a settlement matrix is settled, how do we take up the follow-up actions after that, which would involve updating the settlement balance and the position of the FSPs. So that's what we try to depict here in this diagram. And we have a good design with that. Vijay, Michael, Jason, and we were able to look at this and agree that this will work. We now will proceed into implementation of this. Thank you. We'll pass this on to Jason for the rest of the presentation.
I'm not as tall as the other guys. Let me see. There we go. Good afternoon, everybody. Thank you so much, Sam and Michael. That was great. So there was a very big effort in this last PI to put on the integration work, but also on performance testing. We believe that the settlements was mature enough so that we can put on some real stress testing and see what we can get out of it. So for that, we're going to look at 4 areas today: the environment that we tested against, the process of testing, the actual test cases, and then the observations. Okay, the actual environment. So we used AWS for all of these testings. We have one modest environment, which is running with a very low spec. Both of these are definitely not environments you want to be running in production. And we did that on purpose to see how well settlement would run. And you'll notice there that, with the modest environment, we were running 20 operations concurrently. And for the more amped up environment, we were running 50 operations concurrently. With the services that you see in the services column there, we were running a Docker Compose with a single node Tiger Beetle, with a single settlement service, and then your MongoDB, Kafka, etc. And on the last column there, you would see we were running on an extra large instance and then a 4 times extra large instance. So again, it's really low spec environments. You wouldn't run these in production, but again, it's on purpose. So the testing process. So there's 3 phases that we have designed. The first being the planning. So before you run the tests, you want to, even as an operator, you want to simulate your exact settlement process in order to see will settlement, your hardware and the whole settlement service cater for your needs. And for that, we have a configuration file where you can configure your transactions that you want to be generating, the amounts, the currencies, the settlement models, the participants, the lookups, and then all of these settlement operations, as Michael mentioned. This is just a snippet of the file. The actual configuration file is more complex, and that was done purposefully so that we can, via configuration, get as close as possible simulation of what the hub operation would look like. Okay, so once the configuration has been done, you would use the settlement CLI utility to generate an output file based on that configuration that would randomize data within limits in order to play against an actual environment. So on the right-hand side here, there's an example of such a generated file. When we're actually sending these transfers in real time into settlement to be allocated to batches, or depending on other operations, executing operations like closing, creating matrices, closing matrices, disputing them, these outputs would look differently. Once you've got this single output file, you would then make use of this file to replay against your environment. And the purpose of this is to ensure if you rerun a test, you want to rerun it as close as possible to a test where you've seen a previous result, so that you can very accurately compare if you change your environment, what the outcomes differences are. Okay, so and that was all done via a JMeter plugin to achieve that. Okay, so the actual test cases, the 2 main things is the 20 concurrent operations, the other one being the 50 concurrent operations. And with one exception, we've done some tests just to see behavioral differences between running a Tiger Beetle and not running a Tiger Beetle, what it would look like. Sorry, just to cover the actual test cases. So the clear transfers, which is a very important hot path operation for settlements. It needs to have great performance in that area, followed by doing lookups on those transfers, lookups on transfers that's been cleared and have been allocated to batches, as well as running settlement reports, closing settlement batches, locking of batches for settlement, and then running final reports for settlement. So in these test cases, we are running an extremely stressful environment, running all of those operations many times per second. So we're going to dig into more detail over there. So it really doesn't closely resemble what you're actually going to run in production, because it will not be nearly as strenuous in production, unless there are some really extreme cases. But yeah, we have yet to see those. Okay, so the results. So in the modest environment, we were simulating 20 operators with multiple, all of those use cases that we've just seen being executed concurrently. And then, looking at the results. So not astronomical figures here, but given the environment, it is still not too bad, in my opinion. So we're looking at about 700, maybe a little bit higher TPS rates here using MongoDB. And these, again, it's performing writes and reads and doing many, many operations, all simultaneously, all of the possible endpoints and API calls supported by the settlement service. And then in the next slide, we can see there's not really a big difference whether you're running Tiger Beetle or not running Tiger Beetle. The system is already under so much strain that it's just struggling actually to keep up with all the stress. Okay, so then the second part where things get really interesting is we then used an amped up environment, which is 4 times stronger than the modest environment. And over here, we were able to get 4,500 transactions per second, which is quite impressive given you're doing so many operations at the same time. And then, let's look at those results. So something very interesting to note here. It might look bad from first glance, but on the first diagram here, we're looking at the Mongo stats, and those will be actual user experiences. So what's happening here is we are sending in transfers to be allocated to batches, but at the same time, you are almost immediately requesting and performing lookups on data that has just been sent to be allocated to batches and matrices to be generated. So it's, again, not a scenario that you'll run into in a production environment, or very unlikely to, but we can see there that the response times for running a MongoDB on that instance is around 30 milliseconds versus running a Tiger Beetle where you have no failure. So that is really, I was very surprised to see these even, because there was 0 failures with running Tiger Beetle, which is just really impressive. And we can look at the response times here is also significantly lower. So that's a great thing to see. And it took many, many runs to get to an area where we could get these type of stats. Okay, and then let's go into a little bit more detail here. As mentioned, the failures here that we're looking at Mongo, if you were to execute these same operations a little bit later than what they were actually executed here, you won't actually have these failures. It's just purely because of I suppose in the Tiger Beetle case, the ability of Tiger Beetle to process those transfers so quickly. So that's really impressive to see. And but still, the stats that we're looking at here for 3 million transactions, and in this case, the transactions would be not just monetary transfers being allocated to batches, it would be various operations being executed. Okay, and then looking at the Tiger Beetle, the only real thing to look at here is that, yes, there was no failures, which is quite impressive. Okay, and then to get back to reality, we ran some tests to, again, simulate 50 concurrent operators. But in this case, we're doing a much more closer to a real world scenario where all we're really doing is allocating transfers to batches, and obviously still using both a MongoDB and a Tiger Beetle database, with the difference that we're not storing the transfers in MongoDB. So here, things look great because we jumped up from 4,500 to 17,000 using a very, in my opinion, still a very modest environment, and not one that might be suitable for POC, but definitely not to run anything in production. So over there, we were running hitting 18,000 TPS, which is you would struggle to find a client that would run that amount of transfer. So that's great. Okay, so yeah, just to recap. So all of this means that the tooling can be used from settlements to replay against environment. So this is really helpful for hub operators to see whether their hardware stack would be sufficient to run settlements and everything that comes with it. And then be able to replay those by modifying configurations in settlement and then modifying hardware to see some other things to other points of interest that we picked up during this last PI, which is very interesting, is the Tiger Beetle user queries is now available, and those were absolutely utilized for running these tests, and it's already supported. So it's just fantastic where you're doing during the stress test, seeing just the vast amount of transfers that you're looking up from all of these batches that's been created, and the speed in which of those are being returned. And then the Redis upgrade. So when we started off the project or this exercise, we didn't include any caching capabilities because we wanted to first just run and see what the hotspot areas are of improving settlement performance. But it became very clear, especially during the batch allocation process, that some caching would really, or settlements would really benefit from caching capabilities there. And it did. We originally started with about 300 TPS, which is not great, but then eventually we were able to get to the 17,000 mark with the hardware that we were running. Yes. So lastly, just thank you so much, Sam and Michael, and the whole settlement work stream and the special settlement special interest group. And also a special thank you to Tsidi for helping out with the slides and the content.